Assalamualaikum and good afternoon everyone. As you can see on the screen now, our topic for today is a telescope as portal of discovery. So, it's a pleasure to introduce you my group members.
Hi, my name is Nur Shakira.
Hi, my name is Najwa binti Zulfaka.
Hi, my name is Naraudatul Balkis binti Muhammad Nasir.
Hi, my name is Nusura binti Zakaria. Here are the subtopics that we will present to you for today. So, let's get started. So, first thing first, what is telescope? A telescope is an optical instrument that employs curved lenses and mirror to magnify the image of faraway objects through involving various phenomena, including reflection, refraction, absorption, emission, and electromagnetic radiation. Telescope is a tool that astronomers use to see faraway objects. Most telescopes and all large telescopes work by using curved mirror to gather and focus light from the night sky. So there are two important properties of telescope. The first one is light gathering ability. The better a telescope can gather light, the better you will be able to see faraway star and faint objects in the sky. The second is magnification. The magnification of a telescope describes how much larger the telescope can make objects appear. So now I will tell you the history of the telescope. The telescope has undergone an enormous transformation since it was first patented in the 17th century. So the first thing is who invented the telescope. It is not known who first invented the telescope, but Hans Lippershey was the first person to patent the telescope in 1608. His device called Lucer able to magnify an image up to 3 times. After that, Galileo heard about Hans Lippershey's ingenious device via his friend in 1609. He immediately set about designing and building his own telescope. Although he had never seen Hans' device, nonetheless, he was able to make significant improvement on the performance of his telescope, reaching magnification of around 20 times. In 1668, Sir Isaac Newton patented his revolutionary reflecting telescope design that resolved the drawbacks of the previous telescope. In 1789, William Herschel invented the most efficient design of advanced telescope in history, which was named after him, called the William Herschel Telescope, WHT. WHT is a 165 in a near-infrared reflecting telescope that could go beyond the reach of the universe at that time. In 1924, Edwin Hubble created the Hubble telescope, which is one of the great NASA's observation that was launched into low Earth orbit in 1990 and remains in operation. The Hubble telescope is a space telescope that can observe other galaxies.
Assalamualaikum and hi everyone. I am the next presenter. Alright, we will move to the eye and camera everyday light sensor. Okay, what are eyes? Eyes the organ of the sight. The eye has a number of components. These components include but are not limited to the cornea, iris, pupils, lens, retina, macula, optic nerve, choroid, and vitreous. Okay, next slide is about the eye and vision. Human ability to see starts when light reflects off an object and enters the eye. As it enters the eye, the light is unfocused. So, the first step is focusing light rays onto the retina, which is the light-sensitive layer found in the eyes. The second is once the light focus, it stimulates cells to send millions of electrochemical impulses along the optic nerve to the brain. And the third is section the brain at the back of the head interprets impulse, allowing us to see objects. Okay, next slide is the refraction of light by the eye. Light entering the eye is first bent or refracted by the cornea, the clear window on the outside front surface of the eyeball. Next, the cornea provides most of the eye's optical power of light bending ability. After the light passes through the cornea, It is bent again to a finer focus adjusted by crystalline lens in the eye. And next, the lens focus light on the retina, and this is achieved by ciliary muscle in the eye. Okay, now we will move to next slide. That was about the camera. How does a camera work? Camera capturing or recording characteristics of the light from the subject. First, a camera focuses light and captures the image with a detector. Second, digital cameras detect light with charger-coupled device that called CCDs. CCD detectors are similar to those used in modern telescopes. Okay, next slide is about the main parts of the camera. As you guys can see at the diagram, there was shutter, mode dial, hot show, pentaprism, grip, image sensor, and lens release camera on the body of the camera. Next, in part of camera is camera body. A camera body is a light-proof box. There are also located controls for exposure, settings, and others effects. Next is camera shutter. When the camera shutter release button is pressed, the camera shutter opens and any light flowing into the camera lens is direct through the lens aperture and the open shutter to the camera's image sensor. Shutter speed determines the amount of the time the light is exposed. Next is camera lens aperture. The amount light that reaches the image sensor is determined by size of the camera lens aperture opening that has been set. Next is memory card. The colors and characteristics of the light that the image sensor and then saved to the camera's memory card. So next slide is about human eyes vs camera. So this is comparison of the similarities in the working of human eye and a photo camera. Cornea is the outer cover for eye, while lens is outer cover camera that has transparent glass sits in front of the camera box. Aperture is like an iris for camera that the aperture size refers to how much light is let into the camera. For an eye, retina is formed an image, while for the camera image is formed over a film. And lastly, camera has a hole through which light enters the lens, same as eye pupils.
Next, telescope and technology. X-ray telescope. The first X-ray telescope was the Apollo telescope mount, which studied the sun from on board the American Space Station Skylab. It was followed during the late 1970 by two high-energy astronomy observatories, which explore cosmic X-ray sources. X-ray telescopes are designed to observe the X-ray region of the electromagnetic spectrum. X-ray from outer space cannot be observed from the ground due to absorption by the atmosphere, so X-ray telescope must be launched into orbit. Their mirrors require a very low angle of reflection, typically 10 minutes to 2 degrees. These are called glancing incidence mirror. In 1952, Hans Walter outlined 3 ways a telescope could be built using only this kind of mirror. X-ray telescope must use a different design than optical telescope. The high-energy photons light to penetrate mirrors instead of reflecting off them. The mirrors that focus X-ray are made to be almost parallel to the incoming rays. The X-rays will be glanced off of the coated, usually with gold or nickel mirrors. The mirrors used on the Chandra X-ray Observatory are coated with iridium. By using X-ray telescope, Chandra has imaged the spectacular, glowing remains of exploded stars and taken spectra showing the dispersal of elements. Chandra has observed the region around the supermassive black hole in the center of our Milky Way and found black holes across the universe. Chandra has traced the separation of dark matter from normal matter in the collision of galaxies in the cluster and is contributing to both dark matter and dark energy studies. As its missions continues, Chandra will continue to discover startling new science about our high energy universe. Next, infrared telescope. An infrared telescope is a telescope that uses infrared light to detect celestial bodies. Infrared light is one of several types of radiation present in the electromagnetic spectrum. Infrared telescope may be ground-based, airborne, or space telescope. They contain an infrared camera with a special solid-state infrared detector, which must be cooled to cryogenic temperatures. All celestial objects with a temperature above absolute zero emit some form of electromagnetic radiation. In order to study the universe, scientists use several different types of telescopes to detect these different types of emit radiation in the electromagnetic spectrum. Some of these are gamma ray, X-ray, ultraviolet, regular visible light, optical, as well as infrared telescope. Infrared telescope can detect objects too cool and therefore too faint to be observed in visible light, such as planets, some nebulae, and brown dwarf stars. Also, infrared radiation has longer wavelengths than visible light, which means it can be passed through astronomical gas and dust without being scattered. Thus, objects and areas obscure from view in the visible spectrum, including the center of the Milky Way, can be observed in the infrared. 8 infrared space telescopes have been operated in space. They are infrared astronomical satellite, operate 1983, a joint mission of USA, UK, and the Netherlands. Infrared Space Observatory, operate 1995 to 1998 ESA mission. Midcoast Space Experiment, operate 1996 to 1997 BMDO mission. Spitzer Space Telescope, operate 2003 to 2020 NASA mission. Akari, operate 2006 to 2011 NASA mission. Herschel Space Observatory, operate 2009 to 2013 ESA mission. James Webb Space Telescope, operate 2022 NASA mission. In addition, SPIRITS is a telescope scheduled for launch in 2025. NASA is also planning to launch the Nancy Grace Roman Space Telescope, originally known as the Wide Field Infrared Space Telescope, in 2027. UV Telescope. Ultraviolet Telescope. Telescope used to examine the ultraviolet portion of the electromagnetic spectrum between the portion seen as visible light and the portion occupied by X-rays. Ultraviolet radiation has wavelengths of about 400 nanometers on the visible light side and about 10 nanometers on the X-ray side. Earth's stratosphere ozone layers block all wavelengths shorter than 300 nanometers from reaching ground-based telescope. As this ozone layer lies at an altitude of 20 to 40 km, astronomers have to resort to rockets and satellites to make observation from above it.
So now I will continue on basic of handling telescope. First and foremost, we have to consider the type of telescope because different type of telescope are better for different types of viewing. There are three basic telescope types. The first one is refractor, the second one is reflector, and the third one is catadioptric. The refractor basically has a long thin tube with an objective lens at the front that collects and focuses the light. This one is better for viewing the moon and planets, usually giving a nice image. It travels well and doesn't need much maintenance. A reflecting telescope is also called a reflector. It works by using signals or a collection of curved mirrors to reflect light and create an image. Reflecting telescopes are extraordinarily popular for astronomy, and many famous telescopes such as the Hubble telescope and the popular amateur models use the design of the reflecting telescope. The last one is the catadioptric, is a compound telescope. It combines both lens and mirrors. They are good photographic telescope and they are a lot easier to carry than the reflector. So here the picture of three basic telescopes. The other basic of handling the telescope are you have to consider where do you live. You will need a different power level considering where you are, where you want to observe the object that you want to see. Also, you have to consider what you want to look at. Objects like planets, moons, and closest stars need a high power, good contrast, and sharp resolution in a telescope. And the last part is you have to consider the power of capabilities of your telescope. People generally have mistaken impression that more power automatically means higher resolution and better viewing, but this is not actually true. But high power simply dilutes the brightness of the image and amplifies any blurriness. So here you will know on how to use your telescope. First, you have to make sure your tripod is level. Step number 2, you have to align your telescope. You will need to ensure that your telescope is properly aligned so that it will be able to find celestial objects. Step number 3, align the finder. View it through the finder and make adjustments so that the object is centered properly. This is important to do before you use your telescope to find objects in the sky. Step number 4, always start with a low power eyepiece. Number 5, use your focuser. Always use this to focus the image so that you can capture as many details as possible. Step number 6, use filters. Filters help to reduce the glare around you so that you can see better the planet and stars in a greater detail and color. Step number 7, let your eyes adjust. Step number 8, you have to find something to look for. You should find something that you want to look for with your telescope. And last but not least, step number 9, you have to choose the right place.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shakira binti Burhanuddin. I will explain to you guys about gamma ray telescopes and how can multiply telescopes work together. So for the first slide, I will tell you about the gamma ray telescope. So gamma ray telescope can be used to observe non-visible light. Also, it is one of the instruments designed to detect and resolve gamma rays from sources outside its atmosphere. So as you can see at the slide, I already take the part of gamma ray. So this chart shows the different wavelengths of light. The shorter the wavelengths, the more energy the radiation has. Gamma rays have the shortest wavelengths. They are the highest energy form of light. The gamma ray sky is spectacularly different from the one we perceive with our own eyes. Gamma ray telescopes must use sophisticated techniques that track the movement of individual gamma rays to construct an image. So as you can see at the slide, this is the Fermi Gamma Ray Space Telescope. The Fermi Gamma Ray Space Telescope is a NASA spacecraft. It is in space studying in the most powerful sources of radiation in universe. So, are you guys wondering how does it work? Come on, let me explain more. So, Fermi uses a multi-layer sandwich of converter and detector materials. When a gamma ray enters the front of the detector, hits a converter legume made of dense materials such as lead, which causes the gamma ray to produce an electron and a positron. The electron and positron then continue to traverse the disco passing through layers of detector materials. This laser track the movement of each particle by recording side brief of electric charge along the layer. This ray of burst allows astronomers to reconstruct the energy and direction of the original gamma ray. Tracing back along that path point to the source of the ray out in space, this data can be used to create an image. So, the next slide is how can multiply telescopes work together. So, is it possible for multiply telescope works together? Definitely yes. There is a powerful technique for linking multi-scopes known as interferometry. With interferometry, reduced randomness can combine the signals from many antennas, many telescopes. It allows them to create an image much brighter and sharper than a single antenna dish. Interferometers are used to increase the resolving power of a telescope, and VLA or very large array is one of the interferometers. I will continue the next part. That is the scanning the sky. Okay, as for scanning the sky, there are a few important steps that you need to know. As for the first one, it is learn the sky. First, you will need to figure out what you looking for first. Firstly, you need to find out timing, place, weather and so on. Next, going out on a moonlight night will not get you very far if trying to observe the stars, for instance. Besides that, look at books on stars and constellations. This will tell you when the best viewing times are and when the planets are easiest to be seen. Last but not least, examine sky charts so that when you are out in the dark, you know where to point your telescope. And lastly, train your eye. The important steps to scanning the sky is choose your spot. Choose your spot carefully. You will need to consider light pollution. Try to avoid decks and blacktop driveways and concrete. Footsteps on a deck can cause vibration in the image. Blacktops driveways can create thermal issues for your telescope. Also, practice is most important steps to scanning the sky. First, practice setting up your telescope, then pointing to the correct part of the sky before you start fiddling around at night. The last important thing is in scanning the sky is be comfortable. You need to dress appropriately. If it is going to be cool, make sure you have the right clothes on and bring along a canister of something warm. So, the next slide is telescope in the sky. I have a question. Is there anyone around you loves stargazing? Yes, most of us love stargazing, right? Obviously at the night sky. The next time you gaze up at the night sky, you are likely to spot a twinkling star, but it's really twinkling. What looks like a twinkling star to your eyes is actually steady starlight that the Earth's atmosphere has distorted or bent. Also, the visual effect of this distortion is like looking through a glass of water at an object.
So that's all from us. Thank you and have a nice day.